So hello guys, what's up? We are back again with another question from our level up series. And today our question is minimum substring partition of equal frequency. Yes. So let us understand what this question states. So in this question, we will be given a string and we need to find out the minimum number of balanced substrings. Now, what is a balanced substring? A balanced substring is a string where each character in the string occurs the same number of times. So let us understand it with the help of an example. For example, if I have a string FABCCDDG, then I can partition it into three substrings having such that each substring is a balanced substring. Now, what do you mean by a balanced substring? The frequency of every character in that substring should be same. For example, in this FAB, then CCDD, here all the characters come once. CCDD, all the characters are coming twice. In G, all the characters are coming once. So there can be variety of ways. For example, I can distribute like F, then another string A, then C, then B, then C. I can individually make let's say how many characters? 8 characters. So I can make 8 strings, 8 substrings of one length each, which are balanced. So we need to return minimum number of substrings which are balanced, and we can make out from this expression. So clearly we need to try variety of ways, or you can say all possible ways. So hence the intuition develops of trying dynamic programming or trying all possible ways. Now we will try to follow what the problem has stated. So we will start from an index. Yes, we will start from an index and we will look for further occurrences. We will, okay, let us see. If I start at I is equals to 0, for example, from F, then I know that F is the answer. Then I will try for FA, FB, FC. And likewise, I can try for all the characters and I will take minimum of that answer. So you will understand it better when we will see the code. Let us see the code actually. What is happening? So we are calling a solve function where starting index is 0 and with a DP array. Now, just a second. Yes. Now let us understand the core part, what we are doing. See, we have an index. Initially, let us say it is 0. Then we are trying from that index up till the length. And meanwhile, we are calculating the frequency. And what we are doing, if the frequencies are equal, that means that sub-array is a possible answer. Then we are storing it as we are adding one and then trying for another possible way, where index we pass as j plus 1. And we will finally take minimum of all. So let me just repeat what I said. So if we are at index, if we are at some index, let us say, just a second. Let us say this is our string A, B, B, let us say CD. This is our string. Then from 0 we will start. So firstly we will consider this subarray, then this. Now this is also a valid subarray. This is also valid subarray. So we will add it up in the answer and we will call solve from here. So this A was a valid subarray, then we will call solve for here. Similarly, we will try for AA and then we will call again solve function for the rest of the string. So this way we are doing it. Now let us see the R frequencies equal code. So again, it is very simple. We are passing on the map and we will just check if the firstly we will have previous frequency as -1, and we will equate it to the first occurring previous frequency. So anytime if the previous frequency is not equals to pair dot second frequency map of which we are using, we will return a false. Now, if all the frequencies are equal, which is the demand of the question, we will return a true, which will make sure that we have one valid subarray, and then we will call for other from that particular index, and lastly we will take minimum of all. So yeah guys, this was all from this question. Thank you so much guys for watching this video. Make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much guys. We shall see you next time.